Hi children, welcome to the online classes. This is Sai Kumar. I am physics faculty of Montessori's English Medium School Palakul, LR So today in this class I am starting a lesson of physics chapter from the science textbook, and our lesson is motion and time. So what do you mean by motion? What is meant by motion? What is the meaning of motion? So in your daily life, we will find several objects around us in moving. We will find several objects which are moving. The motion is nothing but movement. It is related to the movement. So motion is nothing but the similar word to the motion is moving. If you observe any object is moving, then the object can be said to be in motion. But what is the real definition of the motion? So this is the approximate meaning of the motion. But in physics, we need to know the exact definition of the terms we are getting. We need to know exact definition of the terms. So the approximate meaning of the motion is moving. So what do you mean by moving? So when you will say an object is in motion. For example, let us observe me only. Just study about me. I am an object in the nature. So can you say that I was in motion? No. How? Why you are not saying I was in motion? Why? Because the position of me was not changing. I was still standing here only. That's why you can say that I was not in motion. I was not moving. If my position was changing, then you can say that I was in motion. If my position was changing, then you can say that I was in motion. So when you will say an object will be in motion, so you can say that an object in motion whenever its position is changing. For example, initially I was situated here and I was walking on the ground. So here the position was changed. Initially I was standing here and later I was shifted to this place. So what happened here? The position was changed. So what is motion? An object is said to be in motion if its position is changing with time. Its position has to be changed with time. Along with the time, if its position is changing, then the object will be said to be in motion. For example, so now we will measure the time. During motion, we will measure the time using a clocks, or you can measure the time using stop clocks. You know the stop clocks are also available in our digital clocks. So just start the stop clock and start moving. So after some time, I just stop walking. So what happens here? My position, the change in position was stopped. So initially I was in motion. Later, after some time, I came to rest. So the position has to be changed along with the time. The position has to be changed. Then only it can be called as motion. So what is the definition of the motion? An object is said to be in motion. An object is said to be in motion. In motion, if its position is changing, with time. So then the object is said to be in motion. So motion is nothing but a change in position with the time. So in your daily life, you will observe several vehicles around us which are in motion. So you will observe vehicles moving from one place to another place, which means that the position was changing. The vehicle's positions was changing. So you can also experience the motion yourself by walking along on the road. You can experience the motion. By walking or running or jogging, you can experience the motion. So if its position was changing with the time, then the object is said to be in motion. So if its position was not changing with time, so I was standing here only, my position was not changing, then what you can call it as? So it can be called as rest. It is at rest. If the position was not changing with the time, then the object is said to be at rest. So now my position was not changing. So what does that mean? I was at rest. Now the position is changing. The position of me was changing. Then I was said to be in motion. So if an object is said to be in motion if its position is changing with time, and rest is nothing but an object said to be in rest, if its position is not changing with the time. If its position is changing with the time, then it is motion. If its position is not changing with the time, then it is rest position. Then the object is said to be in rest position if its position is not changing. If its position is not changing. So let us discuss an important concept of motion. So you will observe vehicles or any persons around you in motion. They will, if they are walking around you, if they are moving around you, you can observe a change in position. So the objects can be said to be in motion. So let us consider some examples. Let us consider a tree or any electric poles. Can you say that these tree or electric poles are in rest or in motion? These objects were always are at rest, or you can consider they are in motion. Is there any possibility of motion in those objects? So let us see about that. Let us learn about the concept of motion in depth. So for example, let us imagine that you and your friend are traveling in a bus. You and your friend were traveling in a bus. So can you say that your friend was moving, is in motion? Just you are standing, your friend was standing in front of you. Then you can you say your friend is in motion or rest? What you can say? The bus is moving and both of you and your friend are inside the bus. The bus is moving. What you will say? The friend is in motion or at rest? So with respect to you, the friend position was not changing. He was standing in front of you only. His position was not changing, and hence your friend will be considered as rest. Your friend will be considered as rest. Why? Because he was standing in front of you and his position was not changing, and hence with respect to you, your friend was in rest position. For example, if the same you is observing your friend from the outside of the bus, you are observing the friend outside of the bus, the position of your friend was changing along with the bus. You are observing your friend outside of the bus. Then what you will observe? The position of your friends will changes. So then in that case you can consider your friend is in motion. If you are in the bus along with your friend is at rest. If you are outside the bus and observing your friend, then your friend is in motion. So the motion is related to the observer. The important point is the motion is related to the observer. So according to the observer, you can say that whether the object will be in rest or motion. So our motion depends on the observer. So whenever you are traveling in a train, you will observe the trees outside the train are moving away from you. So what does that mean? With respect to you, the trees are moving away from you. With respect to you, the position of the trees are changing. So then in that case, you can say that the trees will be also in motion. The trees is in motion. Why? Because with respect to the observer, the motion is related to the observer. It depends upon the observer. It depends upon the motion. The concept of motion depends on the object and along with the observer. So if you are traveling in a train and you will observe the trees will be in motion. Okay. So trees in motion when you are observing from the train. When you are observing from train. So this motion is a relative concept. That's why it is called as a relative concept. Motion is a relative. Why? Why we will call the motion as relative? Why? Because it depends on the observer. It is related to the observer. Motion is relative. Motion is relative. Why? Because motion is related to the observer. So with respect to the observer, an object can be in motion or maybe at rest. It depends upon the observer and object also. It depends on the observer, both on the observer and object. If you are observing your friend outside of the bus, he was in motion. If you are observing your friend from the inside of the bus, then he will be considered at rest. So depending upon the position of the observer and object, the motion, the concept of motion will be depends. So hence the trees and the electric poles can also be considered as motion in some cases. What are those cases? When you are traveling in a bus, when you are traveling in any vehicles, then the trees can be considered as in motion. So motion is a relative concept. So you can also find some objects will be in motion. So you can also find some objects which is in motion, and so you can also find at rest depending upon your position, depending upon the position of the observer. So let us learn about another concept, that is uniform motion and non-uniform motion. So now you have understand that the concept of motion. What is motion? If the object position was changing with respect to the observer and along with the time is called as motion. If its position was changing with respect to the observer, then the object is said to be in motion. So let us learn about uniform motion. So what do you mean by uniform motion? So let us see with an example. So I was just roughly drawing a distance scale, and this is 0, this is considered as 1 meter, and this is 2 meters, this is 3 meters. Just assume that initially I was at 0, and consider a stop clock. So when I was at 0, the stop clock is showing a readings of 0 seconds. So just start the stop clock and find out the time in that. So now I was traveled a distance of 1 meter. So I have traveled a distance of 1 meter, and the time taken to travel that 1 meter is 1 second. So what I have observed in the stop clock, when I have reached this 1 meter of distance, the time taken in the stop clock is denoted as 1 second. So after 2 seconds, I have reached to a distance of 2 meters. I have traveled 2 meters of distance in 2 seconds. So if you observe my distance traveled in 3 seconds, I have traveled 3 meters of distance. So I have traveled 3 meters in 3 seconds. So if you observe in the time gap, what is the time gap here? In the 1 second of time gap, I have traveled a distance of 1 meter. From here to here, what is the distance? It is 1 meter. So in the 1 second, I have traveled a distance of 1 meter. And in the next second, I have traveled a distance of again 1 meter. So what is here 1 second? It is the time gap. We will call this time gap as time interval. What we call it as time interval. So during school hours you will get interval, right? So what do you mean by interval? It is a gap. It is just a rest gap for you. So time interval means time gap. So in 1 second interval of time, I have covered a distance of 1 meter. And in next 1 second time gap, I have covered a distance of 1 meter. So initially at 0 seconds, I was at this position. After 1 second, I was at this position. That means I have traveled a distance of 1 meter. And in the next second, I was at this position. That means how much the total distance I was traveled? 2 meters. And what was the time taken? 2 seconds. So in the first second, I have traveled 1 meter of distance. And the next second, I have traveled again 1 meter, total 2 meters. And in the next second, I have traveled 1 meter, and the total distance I was traveled is 3 meters. So here what you will observe, I was covering same distance for same interval of time. What was the same distance? For every second, I was covering a distance of 1 meter. For every second, I was traveling a distance of 1 meter. Such a motion is called as uniform motion. Such a motion is called as uniform motion. So, what do you mean by uniform motion? If the body travels equal distances, these two distances are equal and time intervals also equal. If the body covers equal distances in equal intervals of time, then the motion is said to be uniform motion. So in the first second, I have traveled a 1 meters of distance, and in the second second, I have traveled a total 2 meters, but in the second second also, I was traveled only 1 meter. In the third second, I was traveled again 1 meter of distance, and the total distance I was traveled is 3 meters. So to travel 3 meters, I was taken 3 seconds. So in this way, what you will observe is I was traveling equal distances. I was traveling equal distances in equal intervals of time. Such motion is called as uniform motion. So what do you mean by uniform motion? If the body covers equal, if the body covers or covers equal distances in equal intervals of time, if the body covers equal distances in equal intervals of time, then the motion is called as uniform motion. So in uniform motion, you will cover equal distances in equal intervals of time. For example, in the previous example what we have discussed, for every half second I was covering a distance of 1 meter. For every half second I was covering a distance of 1 meter. So this is nothing but uniform motion. For example, if you are traveling on a bike with a speed of 30 kilometers per hour, you are traveling with the same speed. What is that speed? 30 kilometers per hour. So what is the distance covered in first hour? In 1 hour, you will travel a distance of 30 kilometers. What does this mean? If you are traveling with a speed of 30 kilometers per hour, you are traveling 30 kilometers per hour. So in the first hour, you will travel a distance of 30 kilometers. And in the second hour, you will again travel a 30 kilometers, and totally you will cover a distance of 60 kilometers, right? So what was happening here? You are traveling equal distances in equal intervals of time. Here, what is the equal interval? 1 hour. For every 1 hour, you are traveling a distance of 30 kilometers. So this is nothing but uniform motion. So when you will say the object is in uniform motion, if the body covers or if the object travels equal distances in equal intervals of time, then the object is said to be in uniform motion. So you can also consider the seconds hand of the wall clock. If you consider the second hands of the wall clock, what is the type of the motion? It is a uniform motion. It covers a half of the distance for every half minute. It covers a full circle for every 1 minute. The seconds hand will cover a full circle of distance for every half meter. So after 1 minute, this seconds hand will cover a complete distance, and again after 1 minute, this second hand again complete the same distance. Here the seconds hand in the wall clock covers equal distances in equal interval of time, that is 1 minute. In 1 minute, the seconds hand is repeating the same distance, is traveling the same equal distances. So in the 1 minute of time gap, the seconds hand is traveling same distances. So that is nothing but uniform motion. The seconds hand is covering equal distances in equal intervals of time. So this seconds hand can also be an example of uniform motion. If the object covers equal distances in equal intervals of time, then the motion is said to be uniform motion. Then what is the And again, next concept is non-uniform motion. Non-uniform motion. So this is exactly opposite to the previous definition. That is, if the body covers unequal distances in equal intervals of time, then the object is said to be in uniform motion. If the body covers unequal distances, let us see an example. Let us discuss an example. If body covers an unequal distances in equal intervals of time, then the motion is called as non-uniform motion. So exactly same as the above, then the motion is called as non-uniform motion. So let us see an example. So just observe me only. So in the first second, I was traveled a distance of 1 meter. In the second second, I was traveled a distance of 2 meters. What happened here? In the first second, I was traveled 1 meter, whereas in the second second, I have traveled a distance of 2 meters. Totally, how much distance I was covered? I was covered a distance of 3 meters. For example, let us consider a scale, a distance scale here. Just measure the distance traveled by me. So this is 0, this is 1, this is 2, this is 3. So just observe my motion. So in the first second, I was here. So how much distance I was covered? It is 1 meter. So in first second, I was covered a distance of 1 meter. So again, after second, so the time taken to travel this distance is 1 second, and for the same 1 second of time, now I was traveled a distance of 2 meters. This is 1 to 3 means how much distance? It is 2 meters of distance. So in the first second, I was traveled 1 meter of distance, whereas in the second I was traveled a distance of 2 meters. So this is, I was covering unequal distances. In the first second, I was covered 1 meter of distance. In the second, I was covered a distance of 2 meters. So here, I was traveling unequal distances. These two are not equal. Whereas the time difference is equal. The time is same. Here, the time taken to travel 1 meter is 1 second. And here, the time taken to travel 2 meters is 1 second. So in both the cases, the time intervals are equal only, but the covered distances are unequal. If the body covers unequal distances in equal intervals of time, in the same gap of 1 second, I have traveled unequal distances. In the first second of time, I was traveled 1 meter, and in the next second of time, I was traveled 2 meters. So what happened here? The distance was varied. Thus, for the same second only, for the same 1 second of time gap, here I have traveled 1 meter and here I have traveled 2 meters. So this is a non-uniform motion. So if the body covers unequal distances in equal intervals of time, then the object is said to be in motion. So this is about the concept of motion, uniform motion and non-uniform motion. So in the next class we will learn about different types of motions. Thank you.